Good day, everyone. Welcome to Science for High School with Marivet Education Center. My name is Master 11, and this series is for Math M.3. Now, we will discuss the topics all about energy changes in chemical reactions in everyday life. Here are our objectives for this lesson. First, the students will be able to analyze endothermic and exothermic reactions from a change in thermal energy during chemical reactions. Second, students will be able to learn different examples of chemical reactions including their chemical equations. Lastly, students will identify the advantages and disadvantages of chemical reactions affecting on the living creatures and the environment. All chemical reactions involve energy. Many of them release energy to the surroundings and others absorb energy from the surroundings. According to the law of conservation of energy, energy cannot be created or destroyed in a system. Therefore, in a chemical reaction, the energy change is the difference of the stored energy between the reactants and the products. Now, we have here the two types of chemical reactions, which is the exothermic reactions and the endothermic reactions. Exothermic reactions is a chemical reactions that releases energy from the system to the surroundings in the form of heat. Example, that is burning of woods that will release heat to the environment or to the surroundings. Temperature decreases with progression of the reaction as it releases energy simultaneously. Next is we have here the endothermic reactions. Endothermic reactions is a chemical reaction that the system absorbs energy from its surroundings in the form of heat. Example of endothermic reaction is the melting of a snowman as it absorbs energy from the heat of the sun. Temperature increases with progression of the reaction as the snowman absorbs heat from the sun. As of this moment, we have here some examples of exothermic reactions that usually occurs in our surroundings. First, we have here respiration. Respiration is an exothermic reaction because the carbohydrates present in food are broken down to form glucose. This glucose combines with oxygen in the cells of our body and provides energy. This reaction is known as respiration. Hence, respiration is considered as an exothermic reaction. Second, combustion of fuel such as coal with oxygen. All combustion reactions are exothermic reactions. During combustion, a substance burns as it combines with oxygen, releasing energy in the form of heat and light. Third, we have here the neutralization reactions between acids and alkalis. Since a neutralization reaction between an acid and base releases energy once the two solutions are mixed together, then it is considered an example of exothermic reaction. Fourth, reactions between dilute acids and metallic carbonates. When acids react with carbonates, such as calcium carbonate, a salt, water, and carbon dioxide are made. The carbon dioxide causes bubbling during the reaction, which is observed as fizzing. It can be detected by passing the gas through lime water, which will go cloudy. Also, the reaction of metal carbonates with acids is exothermic. And lastly, we have here reactions between dilute acids with metals. When a metal reacts with dilute acid, salts are formed. During this reaction, hydrogen gas is evolved. In other words, when a metal is added to dilute acids, salt and hydrogen gas are formed. Sulfate salts and chloride salts are formed when metals react with dilute sulfuric acid and hydrochloric acid. Also note that these are the most common examples of exothermic reactions that are occurring in our surroundings. Now, we have here examples of endothermic reactions that are also actually common in our surroundings. First, we have here thermal decomposition of carbonate and nitrate salts. Thermal decomposition itself is an example of endothermic reaction. It is a reaction that gains energy from the surroundings. Thus, thermal decomposition of carbonate and nitrate salts is an example of endothermic reaction. Second, we have here decomposition of hydrated salts to anhydrous salts and water. Often, a hydrated salt can be converted into an anhydrous salt by strong heating to drive off the water molecules. The mass of the hydrate will differ from the mass of the anhydrous salt by the mass of water that was removed during heating. Third, we have the reactions between dilute acids and potassium hydrogen carbonate. Then lastly, we have here photosynthesis. Photosynthesis is considered an endothermic reaction because during the process of photosynthesis, energy from the sun or sunlight is being absorbed. Any chemical reactions that absorbs heat energy from the surroundings to form products is termed the endothermic reaction. So that is why photosynthesis is also an example of endothermic reaction. Combustion is the scientific word for burning. In a combustion reaction, a substance reacts with oxygen from the air. The energy that the reaction produces can be used to heat water, cook food, generate electricity, or even power vehicles. The products of combustion reacts are compounds of oxygen, called oxides. It is an example of exothermic reaction. Complete combustion of fuels like propane in cooking need to have enough oxygen. Propane burns to form water vapor and carbon dioxide. So, this is the complete combustion of propane equation in both words and chemical formulas. If not enough oxygen is present for complete combustion, incomplete combustion occurs. The result of incomplete combustion is, once again, water vapor, carbon dioxide, and heat, but also produces carbon monoxide. When a piece of iron is left out in open for a while, a film of brownish substance gets deposited on its surface called rust. Rusting occurs when iron is exposed to oxygen in air and water. In areas that have higher humidity, the rusting process takes place faster as the content of moisture in the air is higher. Rusting is an oxidation reaction. Now, we have here below the equation of rusting in both words and in chemical formula. Photosynthesis is the process by which plants use sunlight, water, and carbon dioxide to create oxygen and energy in the form of sugar. Chlorophyll, or what we call the green pigment that can be found in the chloroplasts, is the most important photosynthetic pigment because it is directly involved in the conversion of light energy to chemical energy. The process of photosynthesis is commonly written in words as written below and do have chemical equation, which means that the reactants are 6 carbon dioxide molecules and 6 water molecules are converted by light energy captured by chlorophyll into a sugar molecule and 6 oxygen molecules as their products. Acid rain is a rain or any other form of precipitation that is unusually acidic, meaning that it has elevated levels of hydrogen ions. It can have harmful effects on plants, aquatic animals, and infrastructure. One of the reasons of the formation of acid rain is when a clean water will react to carbon dioxide in the air to form carbonic acid. a compound of elements which is composed of hydrogen, carbon, and oxygen. It is formed in small amounts when its anhydride carbon dioxide dissolves in water. Air pollution also makes our rainwater become acidic. Oxides of sulfur and nitrogen from the combustion of fuels in vehicles and factories react with the rainwater to form acid rain. Sulfuric acid is one of the products that creates acid rain. It is when sulfuric trioxide will react to water. Another example that when a nitrogen dioxide gas reacts with water to produce nitric acid and nitrogen oxide. Now, we have here acids reacting to different compounds. An acid is a substance that donates protons or accepts a pair of valence electrons to form a bond. Some examples of acids are hydrochloric acid, sulfuric acid, and ethanoic acid. Acids react with the most metals to form hydrogen gas and salt. Nevertheless, not all metals react in the same way to acids. When an acid reacts with metal, salt and hydrogen gas are produced. Example of an acid reacting to metal is sulfuric acid that reacts to magnesium that will have a product of magnesium sulfate and hydrogen gas. When acid reacts with metal carbonates, it will form corresponding salts, carbon dioxide, and water. Example is that hydrochloric acid on reaction with sodium carbonate to form sodium chloride, carbon dioxide, and water. Another reaction in acid is when it reacts to metal oxides that will produce a product of water and salt. Example of it is when sulfuric acid reacts to copper oxide. Copper oxide is a base. Therefore, the reaction between copper oxide and sulfuric acid is a neutralization reaction, and the products are copper sulfate and water. The insoluble black copper oxide reacts with the sulfuric acid to form a solution of copper sulfate, which is blue. Salt and water are produced when acids react with metal hydroxides. Metal hydroxides are bases because they neutralize acids. Example of an acid reacting to a metal hydroxide is when hydrochloric acid reacts with sodium hydroxide to form sodium chloride and water. Another case of acid reaction is when it reacts with ammonia to produce ammonium salt. Example for this reaction is when hydrochloric acid reacts to ammonia that will have a product of ammonium chloride, which is a solid and appears as white smoke. As of this moment, we are done already on acids reacting to different compounds. Now, we will proceed with bases reacting to different compounds. A base is a substance that can neutralize the acid by reacting with hydrogen ions. Most bases are minerals that react with acids to form water and salts. Bases are defined as proton acceptors. Common examples of bases include metal oxides and metal hydroxides. Bases react with acids to produce either salt and water or just salt only. Bases also react with certain metals such as zinc to form salt and hydrogen. Example of base reacting to metal is sodium hydroxide, which reacts to zinc, which will form a sodium zincate along with hydrogen. Chemical reactions found in our everyday life are both beneficial and harmful to organisms and the environment. Besides combustion of fuels, our body carries out respiration to produce energy for our daily activities. There are many chemical reactions occurring in our body to ensure our body works well. In batteries, chemical reactions gives out energy too. Photosynthesis not only makes food but also produces oxygen for all living things to breathe. We make cheese, wine, and kimchi by fermentation whereby bacteria act on the food chemically. Chemical reactions break down dead organisms by turning them into nutrients for other organisms. Aside from being beneficial, some chemical reactions can also bring harm. Rusting makes iron things weak and tarnishes their appearance. We can prevent rusting by applying a protective layer such as paint or grease on the surface of the iron. Undesirable chemical changes by bacteria on our food cause food spoilage. If we accidentally consume spoiled food, we will experience food poisoning. We should keep leftover food in refrigerators and reheat it later when we want to consume it. We also should discard expired or spoiled food. Acid rain and depletion of ozone layer in our atmosphere bring negative effects such as death of aquatic organisms, erosions of some rocks, skin cancer, and cataract. We should reduce the combustion of fossil fuels that releases carbon dioxide. Factories should make sure their emissions are free from harmful gases such as oxides of sulfur and nitrogen. We should limit the release of chlorofluorocarbon, the main substance responsible for the depletion of ozone, into the air. Chemical weapons also and explosives are very damaging. We should reduce or even better halt the production of use of such destructive chemicals. This is the end of our lesson about inheritance of traits and genetic disorders. Thank you for listening and see you on the next episodes. Goodbye.